Ooh, hey everybody. This is Larry. This is day 20th of the Leetcode July Daily Challenge. Ooh, wow, 200 days today. Is that true? I guess so. I mean, I have no idea. Yay, 200 days. But also day 20th of the Leetcode Daily Challenge. Hit the like button, hit subscribe button, join me in Discord. Let me know what you think about today's problem. Today I ran a couple of miles this Saturday, rested a little bit, went to some barbecues, etc. It was very fun. And now I'm finally doing today's problems while I'm eager to go back to bed, to be frank, and just lie down and rest. Man, my body is out of shape. But yeah. That's it. So let's get started today's problem. We have a hard one, so maybe I need to get started pretty soon. We have 1948, delete duplicate photos in system. Due to a bug, there are many duplicate photos in the file system. Okay, maybe I have some idea, depending on, The thing is with Leetcode problems and also just competitive in general, is that sometimes they say something, but they don't really mean it. And what I mean by that is that, they may from here, like, oh, delete duplicate photos in the system. That means something to me, like it's a real thing, right? And then somehow, like, in the constraints, like, oh no, except for this one crazy thing that, like, makes no sense and make it really not this. So I have to be, sometimes I do have to slow down when they try to be like, try to describe it and you're like, oh, maybe I know what they're already gonna ask, but it's nowhere close. Okay, let's take a look. Two photos now on the same level necessary. Identical, they can the same non-empty set of identical photos. Okay. I mean, I think there are a couple of ways to think about this. Actually, they even put it in kind of like a tree format in the visualization, which is actually kind of a helpful format, right? Oh, Wait, maybe I misunderstood it. Let me see. A and B and C and B are the same. Oh, okay. So I think one thing I would say is that is not real life, for example, is that when you find duplicate photos, you don't usually try to delete all copies of it. You want to keep one copy. Like, you don't delete your data randomly for no reason. That's why I'm like pausing. I'm like, am I reading this right? Do you actually want to remove both A, B, and C to B? And it seems like you do. Let me double read this for again. But yeah, and they're obviously not identical because at the root is A and C, but they're, the contents are duplicate, presumably. I think, yeah, I think that's fine, yeah. I think there are a couple of ways we can think about it for this one, and so we will. I'm trying to think. The short story is that we're gonna hash. You can hash the subfolders or subdirectories or whatever, subfolders, and then you could do hash of hashes and stuff like that. So that part I'm not super worried about. I mean, there are some probabilistic / challenging type things about it, but conceptually is a known thing. So I don't think this that part is that bad. I'm still using my Chipotle cup because I have to finish my soda, but this came from Chipotle. Not a sponsored deal, but if Chipotle want to sponsor me, let me know. Because I eat way too much for Chipotle. But in any case, so then, yeah. So let's just say we already have a tree. That's basically what I would do. And then the question is, okay, given paths like this, my question might be, well, do I want to construct a tree? And I think that's the part that I'm not just haven't decided. I mean, there's nothing wrong about anything, but just haven't decided. And a lot of these examples, I think I was just trying to look for one where the children of one of the nodes have multiple nodes, but for some reason they don't have it because they all just have branch off from the root, which is kind of awkward. But enough to explain it, but just yeah. Yeah, and I think the way to do it, or the way that I want to do it anyway, is just by creating a tree. And for here, maybe it's sufficient to just have a node class that I can type correctly, right? And then what's in this node class? Well, I'm trying to think whether I want. Oops. I'm trying to think whether I want the values or the for example the A and the C. Do I want it to be on the edge or on the node itself? And honestly, I'm not quite sure either. Or I'm not quite sure because it doesn't. I don't think it matters. I mean, there'll be different formulations, but I don't think it matters that much. You have to be a little bit careful, but yeah. So then just maybe sub nodes or subfolder, or maybe we could even just call this folder to kind of match what we're doing here. Subfolders is equal to right? And this is literally just like a try, a prefix try. You could like a tree try, something like that. I mean, try is a prefix tree, so but I don't think there's anything necessary prefix about it. At first, we just populate, right? So root is equal to folder, and then we have for path in paths, and then we just maybe we have a helper of maybe we just like add root path, right? And add we have node. Maybe in this case root is already implied. I don't know if that's a great way of doing it even, but here we go current is equal to root for x in path, or maybe d for directory. I don't know. We do current dot subfolder or subfolders d, right? So current is equal to this, but if it doesn't exist, d not in current dot subfolders, then yeah, it's equal to a new folder, right? Pretty standard try stuff, I think, right? And then now that we're done, what I do want to do is do a traversal, right? So maybe I say something like populate hash or something like that of root, right? And again, maybe the root is implicit, I don't know, because we can do it here, right? Because you always kind of only wanted to do it from the root. You could always do it kind of incrementally, but I think that's more awkward. But the idea, maybe that's fine actually. The way that I would write it is something like current dot sub node dot subfolders, right? Dot keys. So we do want to sort it, and there are a couple of ways you can think about these hashing algorithms. I don't know. I'm not super interested in it in the hashing part. You could just use hash, I think. Yeah, okay, right. So basically, yeah. So for f is in this, then we want maybe like the sub hashes, right? So hashes is equal to right, hashes dot append, and we actually want to sort this just to keep it the same consistent format, right? So node or append populate hash of f, right? And then now we just do a function on yeah, return that is one thing about doing it on the node, is that, oh, this is key, so this is wrong anyway, because it should be node dot subfolders of f, but then now, so this returns something. This is maybe the way I wrote it is a little bit awkward, my apologies. I'm trying to think, but basically you want this, and also because basically you want a hash function that is takes a function that is of the node value, right? or the edge value in this case. So basically maybe something like I don't know. Honestly, it's a little bit awkward. Maybe something like merge hash or something of f, and then this, and then return at the end. We just return. So basically now you have a list of hashes from the subtrees, and then now you want to combine them, right? So maybe another merge hash kind of hashes. That's kind of a little bit awkward to use the same thing, so maybe we just go naming things is hard. Or slash maybe the way that I did it. Maybe I could change this a little bit by putting the node value here as well. So then now we can just write that as part of the function, right? So then yeah, then now we can merge hashes. And what we have here is that now just like self.node is you go to right, so just say v. So then now this is folder of root, and then now we create a new folder where the value is d for the directory, and then now this is there, and then now we can just say what is the hash of this, right? Well, it is the combination of all the hashes and the current node, right? So that it's going to be node dot. Maybe this is node dot value, not node dot node. That's kind of confusing. But node dot row and hashes, right? Something like that. And maybe this strip in helper function. Sorry, I'm like really waffling. I mean the algorithm it's not that bad, but oops. But definitely I am struggling a little bit with just being dumb on the implementation. Right, so then you have a value, and then you have a list of hashes. And this part I think is not as interesting. There are a lot of ways you can do hashes, right? So maybe you can even just do like I don't know, hash of v. Sorry, let me return something real quick. I forget. I think this returns what I expect, but I'm not quite sure. That's why. It's been a while. I haven't done Python hash things in a while. B is not. How did that happen? Hash rule type. Actually, I knew that. It needed to be a frozen list or something. But let's just say I just wanted to hash anything. Just can't see what. Okay, so it does give you a number. That's what I was looking for. Because I don't know if it does anything funky. So then now maybe I could just write, yeah, oops. Lock my computer out. Okay, that's fine. Maybe just, what is that? Reduce? I know people write as a reduce, but maybe I don't need to. So maybe for yeah, current age and just maybe even just something like this, just for, you know, I mean, I don't think it's super interesting, but yeah, right? Or like, you know, there are potential for hash collusions and stuff like that, but for now maybe I don't really care about it. But for here we do want to populate the node with it, so maybe we return it, but we also set node dot h is equal to node dot hash is equal to h, and then return h, right? So then now we populate every node. Whew. Right? And then now we can maybe put this, now that we're doing it this way, we can maybe even put in a lookup table, right, of possible collusions. And actually we want this to be a list, and then that all we need is lookup of h is equal to node, and that should be good, right? Because then now for h in lookup dot keys, if lookup of h is, or if length of this is greater than 1, that means there's a collusion, and then we want to remove these nodes. How do I remove this node? I guess removing this node is the same as I mean, there are two ways to do it, right? One is kind of the same as linked list, is actually you need to point it to this node. Another is just to put in something like, I don't know, sub dot deleted is equal to force, and then here maybe you write for node and lookup sub h node dot deleted is equal to true, and then now we just finally get a traversal of the tree, right? So then from the root, so then we just, I don't know. This is actually turning out to be like a very messy thing, even though I think conceptually it's not super difficult, but still a little bit wonky. Maybe it's just wonky because I'm doing it. But yeah, and then right? Oh, traverse node and maybe the current path, right? The current path. And then yeah, and this is just a regular tree traversal, which is that, okay, so if answered or if node dot deleted, we return, right? Otherwise we just do for f in node dot subfolders, traverse f and then path add f or something, or maybe it is actually cleaner if I just put you know, like in what's it called, backtracking kind of way, instead of creating new objects, which is what I was doing. And then, but it shouldn't matter, only because this suggests that answer dot append, yeah, what's it called? Oh, actually I guess just this, right? No, I thought I needed to change it into the string. I don't know why they don't have it in the string format, but in any case, I think that's a little bit cleaner, but it's fine. Did I have a list 3? I think I just clicked on 3 by accident somewhere. Folder doesn't have lookup of h is a folder. Is that right? No, lookup of h is oh whoops. That's why type safety is nice. String object node traverse root for f. I made the same mistake, I think, which is that this is node dot subfolder sub f. Nope. But not too bad. All right. Okay, so I mean, I think we're mostly close to right, but clearly there's, you know, we don't get that. But we actually also removed the b and we removed the b's and not the a and the c. So we actually have to get so the only difference is that the hash. So only minor difference is that actually the hash the only difference is that whether to delete this current node only depends on its children, not its current value. So we have to kind of figure out. So basically, we still want to calculate this to return, but for the purpose of this part, we want it to be. Actually, this part more specifically. I guess the hash, we don't actually use this hash, do we? Huh? We only use it for the purpose of lookup. So actually, let's just get rid of it to kind of remove possible future confusion. But okay. But yeah, so this h has to kind of just take care of the hashes, and then the return value will contain the one with the node. So maybe we write. It's a little bit awkward because I feel like now I have to do both of them, but maybe it's fine. Maybe I could do it this way. And then now merge hashes, right? And then now we do hash of node dot value. It's too hacky, honestly, but and still not right. Why is that not correct? I mean the empty one, but why do I remove a? hashes. My theory is that the A is because A matches the AB, but that doesn't make sense. Or shouldn't have the same hash. So all right, let's take a look at the other examples. Today apparently is a struggle bus day. Example, why we move the CB? Why do I move CB? Why do I move the B part of the CB? That's interesting. AC and then just move. Huh. I mean, and of course I put in the root, but that's easy to remove. Yeah, maybe I could just put it here. I mean, just lazy. I don't think that's a clean way of doing it, but yeah. But why do I remove DA? Okay, well, let's see. We have H and lookup of H, right? I don't know if that's helpful though, because it gives me the nodes. So hash is 0. That's actually a very awkward hash. So that may explain it. If our hash is like, if our hash is kind of being wonky. For hash in array, hash. Merge hashes. Alright, maybe there's something weird, but okay. No dot value and then H, right? So we can kind of look at the subtree and the H real quick. So it does look like we have hashes. So am I doing something crazy? Though the B's having the same hash is kind of crazy, right? Because that I mean, I don't know. And I mean, I probably could honestly. This hashing algorithm was just lazy. We can probably do a little bit better than just XORing all the hashes together. But I'm still curious why this is the same. Because B means because B is an empty. But the other B shouldn't be, right? But the B has hashes. So okay, I guess we can just look up hashes. It's either that or we just didn't create the sub. Yeah, okay, we didn't create the subtrees correctly. Maybe. Oh, I see. Now that I look at this. Wait, where did oh, I'm looking at the wrong example. I was looking at this example with this input, and I was like so confused. Okay. All right, okay, I see. Okay. So then, why did I remove DA? Okay, I'm just being dumb, of course. Which, you know. Okay, so this should be the one that removes the B's, but then this thing gets removed because because it just doesn't have a can I like if H is not equal to 0, because it just means that there are no subfolders. Actually, we could check that more specifically then, right? If that's where we went, try to be as precise as you mean. Is greater than 1 or greater than 0, so it has subtree. Okay, so that's why I was removing all the nodes. I mean, I guess that makes sense, and that's consistent for all our other things. Do I still have my print statement here somewhere? Oh, there it is. I was looking for it. Okay, and I just hit submit. Wrong answer. Oh no. I say oh no also because this is like very confusing. Honestly, it probably is just the XOR function, because XOR is kind of terrible, because I can see how because the way that we have it, this is just the XOR of all the sub values, so we definitely need to do some shifting. I see. Because the reason why this doesn't work, and I was just being lazy to be frank, is because let's say you have two, and this is where I kind of got a little bit too confident, because even though I pointed out earlier, which is that each subtree only has 2 nodes, right? So we have it only branches at the root node. But the case where it is wrong is if you have 1 node, and let's say on the left side you have a subtree that's like A, B, C, and then the other, or something like that, where like basically things cancel each other out when they shouldn't. Maybe there's two B's on the left, then they cancel each other out because of the XOR, because I was lazy. So yeah, so maybe we can just do some kind of shifting thing. Like, I don't know. I think even a small shift should be okay. It could be very long. Okay. I don't know, something like that. And then just let me look for a big prime. I always just look for a 20-digit prime or something. I Google it and I just pick a random one. Maybe that'll work. Yeah. I was just being lazy, to be honest. Oh man. Oh. I guess there's another case where, I mean, we're just dealing with false positives because I was lazy about the hash function. And honestly, I also forgot about this one. I think that's probably the reason why. Yeah, that's probably the reason why, because we didn't do any shifting or craziness here, and so this is probably okay now, but this makes it a little bit awkward. But yeah, so maybe we can just do this times 32 or something. Okay, still wrong. Why? And at this point, I'm just trying random stuff. It's not really a big deal. Is it? Let me see. So B has B. I have to draw it out. I don't think this is something that I can just like look at it and get the answer. So sorry, I have my notebook, but I'm now looking for my pencil. Okay, I'm just drawing out right now. So we have B, D. Okay, actually, let me change my mind a second. Let me put the drawing up so you can see what I'm just trying to draw. But I'm just drawing the example, so there's nothing like I'm not doing anything too crazy. Huh. Oh, there it is. Yeah, so, and this looks, I'm just looking at the thing. There's stuff in the way. I only have one monitor, so you know, it is what it is. Well, okay, so we have B, BD, BDD, BE. We have C, CD, CE, CED. Oh, I see. Because the way that we do the shifting, I see, yeah. Because the way that we do the shifting, and it's kind of lazy, is that we only shift, it's kind of shift by level, to be honest. So here, in a way, because of the way that we do the XOR, but again, just a me being lazy thing. I really should, yeah, this is just a me being lazy thing, because it's something that you could use a template on for sure. How do I adjust this then? I think the other way is just to shift by. Yeah, you convert it to a base. Okay, fine. Yeah. Something like that. I don't know. Right. But then now this one's wrong. It's just dealing with false positives, which, you know, functions are kind of confusing. It is sorted, right? So it should be consistent. Take the current thing. Let's just say start at 1. Maybe that's a little bit cleaner, so that you don't overlap with the 0. Because this is kind of P is equal to 0. Okay, so that looks okay. Am I confident? I mean, again, this is just based on the hashing function. Most of our ideas is right. Ooh, I hope so. Anyway, and this is like keeps getting closer, but not quite. I think what I should have done is just write the hash. Um, yeah, I think this is also a good exercise on not writing your own hash. I think let me just rewrite this real quick. And this is because I actually thought about this earlier, but I was like, ah, maybe I could just show off a little bit. I don't even think that. I think I was just, yeah, like, um, I just thought I could get away with it a little bit, but oh. So then now we just hash it as a string. That's all. That's what I mean. And then now here we can. So basically, we hash the hash values as a string and then concatenate them. So in theory, now it should be better. It's just that I don't know. I thought I didn't need to, but yeah. And then now we have hash. Know that value, right? Yeah. So then now we have hash, string of hash plus hash of know that value, and then return hash of this, I suppose. And maybe we should be okay. It's gonna be a bit slower though, but I guess still fast enough. Hopefully nothing too silly. I mean, I think the lesson here, honestly, I mean, there's some lessons for sure. Is hashing is hard. Don't roll your own. I did, and I kind of got a lot of wrong answers. I probably didn't need to, but what did I do 4 years ago? I probably did something good. I mean, we did the node thing, the hash thing. We kind of, yeah, we wrote our own mod pal craziness, which I was thinking of and could have done, but yeah, as you can see, it's yeah. At the end of the day, just use the native hash functions and then convert them, kind of thing. Coming up your own is hard, especially when you're dumb like me. But yeah, what's the complexity, right? Ironically, I mean, this should be linear. I think the only part that doesn't look linear may be this, where is it? Oh, this hashing thing. But look, but each element, each node gets hashed twice, right? Once here, I guess depends on what you mean by twice, but once here, and then once as part of and someone else's children. So as a result, everything it's hashed twice. So everything is going to be linear in the number of nodes, right? Number of nodes being the size of the input, I think, because the size of the input can have longer nodes, if you will, or longer paths. Yeah, that's all I have for today. Let me know what you think. Like I said, maybe the key thing is don't hash yourself, and let them hash it for you, and just like create and what I did is that I just create hashable objects so that hash does it for me instead of me doing it myself. And as you can see, making a lot of silly mistakes. Which, I mean, like if you look at it, like I was confident about the idea and the algorithms, but hashing was certainly not very easy to mess up. And so in most cases, you want a library. Yeah, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And this is half an hour for a tree traversal video, which is kind of a little bit sad for me. But yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.